The nose is a sensitive organ that needs care and attention. It warms, humidifies and filters 10 to 15,000 litres of air a day and is the main barrier against harmful particles that you may breathe in, such as microbes, pollution, smoke and dust. Regular exposure to such particles can damage this barrier and lead to nasal conditions ranging from the tiny baby who cannot feed because of a blocked nose to adults suffering from rhinitis and rhinosinusitis. In order for us to know how best to treat and prevent nasal conditions, we need to look at what is inside the nose and understand how it works. The nasal cavity extends backwards for about a third of the distance across the inside of the skull. There are usually 3 turbinate bones on both lateral walls of the nose, although some people only have 2 on each side. These bones are covered in a lining which has plentiful blood vessels that can expand or contract. The turbinate bones therefore act like radiators that can alter the temperature of the air before it reaches the lungs. The bones can also make the airflow in the nose turbulent, so particles are deposited on them, and the air is thus cleaned before it reaches the back of the throat. One other fascinating fact is that both nostrils do not function equally all the time. There is what is known as a nasal cycle, with one nostril working maximally for 4 to 6 hours, and then the other one taking over. The airflow is altered by the turbinate bones, allowing their blood vessels to expand. This delicate mechanism is controlled by nerves from the brain stem. There are also paired paranasal sinuses, or air cavities, which can be found in the nasal passages of the skull. These are the maxillary sinuses. These are the largest of all the nasal sinuses and can be found in the maxillary bones underneath the eyes. The frontal sinuses, which are located above the eyes in the frontal bone. The ethmoid sinuses are formed of several small cavities within the ethmoid bone between the nose and the eyes. The sphenoid sinuses, which are located under the pituitary gland at the center of the skull base. It is unclear why these sinuses exist. However, it has been suggested that they perform functions that vary from increasing vocal resonance to decreasing the weight at the front of the skull. Another function is the manufacture of nitric oxide gas, which helps in airway defense. One of the key aspects of nasal functions is the lining, or epithelial cells of the nose. This nasal lining contains millions of tiny little hairs called cilia, which beat constantly with a stiff arm forward stroke and a limp backward stroke. Each cilium contains tiny hooks on its end to embed in the mucus, which traps foreign and potentially harmful particles that enter the nose. These cilia are arranged so that their beating is metasynchronous, so that trapped particles are carried backwards from the front of the nose to the back, where the particles are swallowed together with the mucus in which they are carried. There are also glands and goblet cells, both of which produce this mucus, which occurs in 2 layers, a liquid sol phase in which the cilia can beat and a thicker gel phase in which the particles become embedded. Another nasal function is that of the sense of smell. Smell nerves are located very high in the nose, coming from the first cranial or olfactory nerve and dangling in the upper part of the nose through tiny holes in the skull. Each nerve needs around 30 to 40,000 molecules of an odor to be stimulated, so when the nose is blocked, the sense of smell is reduced. These sense nerves in the nose are also largely responsible for our sense of taste. The taste buds on the tongue are responsible for sweet, sour, bitter, salty, and possibly umami tastes, but every other modality of flavor is experienced via the nose. Loss of the sense of smell can therefore reduce people to being able to taste only these basic flavors. As we can see, the nose is a very complex organ that serves several vital functions and is helped along by a very efficient self-cleaning mechanism. However, we live in a polluted environment, and sometimes that mechanism can get damaged. There are several factors that can reduce ciliary function and number, such as exposure to cigarette smoke, general airborne pollution, or even from using medicated decongestant nasal sprays too regularly. There are also many naturally occurring particles, from plant pollen to dust and animal dander, which can affect proper nasal function. One such condition caused by these particles is allergic rhinitis, commonly known as hay fever. Allergic rhinitis is an inflammation of the nasal lining. Symptoms include nasal discharge, itching, sneezing, and nasal congestion, and is occasionally associated as a cause of conjunctivitis. The sinus linings may also be affected, especially more